Hello everyone, I'm Sujata Paul from D3 Academy. If you dare to dream, you can do it. There is no doubt that people are experiencing extreme anxiety owing to COVID-19 pandemic due to fear of contracting the virus. So please don't panic, and 10th standard students, don't worry at all. You can make it through. Even if you have limited experience with online learning, it will be my pleasure to help you all. Okay, in this video today we are going to discuss about the 10th standard science. So we'll be seeing chapter wise explanations, we'll be doing revision, we'll have problem solving classes and question and answer discussions also. So please like and share and subscribe our channel. First, today we are going to see chapter 1, laws of motion. Laws of motion chapter is divided into three parts: part 1, part 2, and part 3. Part 1, today we are going to discuss part 1. Okay, before going to lesson, first we'll have objectives of this lesson. What are the topics we are going to see? The first thing is a concept of force and motion. The second is mechanics and its types. The third, definitions given by Aristotle and Galileo. Fourth one is inertia and its types, and fifth one is a linear momentum. Okay, before going into chapter, let's have some introduction. Okay, we are doing so many activities in our day-to-day life. Each and every activity has different science aspects behind it. Some we know, some we don't, but still human beings are so curious about things around them. Okay, some bodies are at rest and some bodies are in motion. Rest and motion are interrelated. When a body is at rest, starts moving, a question that arises in our mind is, what causes the body to move? We'll be having this question most of the times. Like, what brings it to rest? What speed up or slows down the body? What is why there is changes in the directions of motion? For all these questions, we are having one answer for the all the above questions is force. Okay, for our common man's understanding, force is defined in only two words, that is push and pull. Okay, one we use to push and another one is used to pull. Okay, this is push and pull. Most of people or kids, like even kindergarten kids today know about what is push and pull, because they are seeing that boards in the malls and clinics, a few public places. Okay, so this is what force, you can easily remember it. What is force? Push or pull. Okay, your body needs a push or pull to move or bring to rest or change its velocity. Okay, hence this push or pull is called as force. Okay, force is defined in a more scientific manner using the three laws of proposed by Sir Isaac Newton. Isaac Newton given a three laws which are most important to define force. This is a general introduction of force. Okay, the next thing we are going to see is mechanics. What is mechanics? Mechanics is a branch of physics that deals with the effect of force on bodies. What it deals? It deals with the effect of force. The effect of force on bodies. How much effect is giving on the bodies? The quantity, amount, the time, all these things comes under the effect. Okay, it is divided into two types. One is a statistic, another one is a is defined divided into divided into two types. One is the statistic, another one is the dynamics. Statistic, it deals with the bodies which are at rest under the action of forces, which are at rest under the action of forces. Okay, it's completely contrary to dynamics, completely opposite to dynamics. Dynamics is the study of moving bodies under the action of forces, moving bodies under the action of forces. Okay, statistic, which are at rest under the action of forces, moving bodies under the action of forces. And dynamic is further divided into two types, that is kinematics and kinetics. Kinematics, it deals with the motion of bodies without considering the cause of motion. Okay, this is 2 points. From this point, one object is moved from and place it to the another point. For kinetics, it does not consider the cause. Who is moving this object, which force is applied, it does not consider any cause of motion. But when it comes to kinetics, it considers the cause of motion. It's totally different from kinematics. Okay, kinematics, it deals with the motion of bodies without considering the cause of motion. Kinetics, it deals with the motion of the body considering the cause of the motion. Okay, next thing we are going to say is force and motion according to Aristotle and Galileo. Okay, what Galileo and Aristotle says about force. Aristotle, he is a Greek philosopher and scientist. Okay, what Aristotle says is the natural state of earthly bodies is rest. The natural state of earthly bodies is rest. Okay, so he's stating that moving body naturally comes to rest without any external influence of the force. The body is come into the rest without any external influence of the force. Such motions are termed as natural motions. Here, natural motions is without any influence of external force. So, it is force independent. Okay, two terms you have to remember according to Aristotle. One is the natural motion, another one is the violent motion. Okay, in natural motion, here the body naturally comes to rest without any external influence of the force. But when it comes to violent motion, okay, what he's proposing is what he proposed, that a force, a push or a pull is needed to make the bodies to move from their natural state and behave contrary to their own natural state, called as violent motion. Here it is force dependent. It's totally opposite from natural motion. Violent force is force dependent. Okay, natural motion is force independent. Further, he said when two different mass bodies are dropped from a height, the heavier body falls faster than the lighter one. Okay. In further, what he is saying is when two mass bodies are dropped from a height, the heavier body falls faster than the lighter one. Just take one heavy ball and one light ball. Light ball like plastic or some heavy ball, rubber ball, and drop both simultaneously from a height. Heavy ball reaches the ground faster than the lighter one. Okay, this is what Aristotle is saying about force. Okay, next thing we are going to say about is Galileo. Galileo proposed four concepts of force, motion, and inertia of bodies. Okay, that four concepts we are going to see. First thing what he is saying is the natural state of all earthly bodies is either the state of rest or the state of uniform motion. What Aristotle said is the natural state of earthly bodies is rest. Here, Galileo proposed is the natural state of all earthly bodies is either the state of rest or the state of uniform motion. This is the first point. The second point, a body in motion will continue to be in the same state of motion as long as no external forces apply. Okay, this is a point to remember. A body in motion, if you're moving in a bus, okay, your body will be in the same state of motion, and when there is a apply of a brake in a bus, your bus will stop directly. Okay, that is, that time your body will not be in the state of motion. Okay, this is what Galileo is considering in the point 2. A body in motion will continue to be in the same state of motion as long as no external forces apply. The third point is when a force is applied on bodies, they resist any change in their state. This property of bodies is called inertia. When force is applied on bodies, okay, that bodies resist any change in their state. This property of bodies is called inertia. They resist. Your body will automatically will resist sudden change in your body. Okay, that is called inertia. Fourth point is a when dropped from a height in vacuum, bodies of different size, shape, and mass fall at the same rate and reach the ground at the same time. First, we saw an object. What Aristotle said is when we dropped one heavy and lighter object, the heavier object falls faster than the lighter one. Okay, but here what Galileo says is when in vacuum, here he is proposing in vacuum, while Aristotle said is direct in normal environment. Here in vacuum, okay, where bodies, we are having different sizes of bodies, different shapes, different mass, fall at the same rate and reach the ground at the same time. Okay, these are the four concepts proposed by Galileo. Next, we are going to say an important topic, that is inertia. Inertia, we already know that when a force is applied on bodies, they resist any change in their state is called as inertia. That state is called as inertia. Okay, it's an inherent property, the existing property of a body to resist any change in a state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force is known as inertia. Okay, there is some external unbalanced force which influences the state of rest or state of uniform motion is known as inertia. Still it resists the property. It's a inherent, it's existing property of a body. Okay, which resists any change in its state of rest or a state of uniform motion, that is called inertia. Here we can see an example. A giraffe sitting in a car and it's driving. We can take it as giraffe or a human. Okay, it's moving in a direction, so it's a motion, uniform motion. Suddenly there is a break or an object, external object or external force which makes his car to stop, and giraffe moved. Okay, automatically it's moved from its space, so this is called as inertia. Okay, it's resisting that movement, but still there is a motion. Okay, types of inertia, there are three types: inertia of rest, inertia of motion, and inertia of direction. The first we are going to say is inertia of rest. The resistance of body to change its state of rest is called inertia of rest. Body is resisting to change its state of rest. Okay, the rest state, it's resisting to change. That thing we call it as inertia of rest. Here we can take it as example. You can able to see here. Okay, where when you rigorously shake the branches of a tree, some of the leaves and fruits detach, they fall down. Okay, here you can able to see that some fruits and vegetable sorry some fruits and leaves of that tree is falling down. When you vigorously shake that branch of a tree, some of the leaves and fruits are detached and they fall down. It's a basic example for inertia of rest. We all have gone through this. Few people like to eat mangoes, so when it's ripened they used to do this kind of thing. They used to shake the tree or branches of a tree. Okay, let's move on to the next topic. Inertia of motion. The resistance of a body to change its state of motion is called as inertia of motion. Here the body is resisting to change the state of motion. Okay, so inertia of rest is to change the, it's to change its state of rest. Here inertia of motion, to change its state of motion. So here we call it as inertia of motion. For example, we can say an athlete runs some distance before jumping because this will help him jump longer and higher. Okay, we just came with the same example as there in your book, so that it will be easy for you to remember and make a difference between inertia of rest, inertia of motion, and inertia of direction. Okay, so these pictures are will be very useful for you to remember. So next we move on to the next slide. The resistance, this inertia of direction, the resistance of a body to change its direction of motion is called inertia of direction. Here body resists to change in its direction of motion. Okay, so here inertia of direction. For example, we have gone through this in our daily activities. Like when you make a sharp turn while driving a car, you tend to lean sideways. Most probably this happens with everyone, so don't forget, remember this. This is a best example for inertia of direction. Okay, you can see it in image also. Okay, let's move on to the next slide. The next topic is linear momentum. What is linear momentum? Linear momentum's main work is to measure the impact of force on a body. What is the impact? To measure what is the impact of force on a body. How much force it's putting on a body to make movements. Okay, the product of mass and velocity of a moving body gives the magnitude of linear momentum. It acts in the direction of the velocity of the object. There is a product of mass. Mass is a weight and velocity is the speed of a moving body, gives the magnitude of linear momentum. It gives the magnitude of linear momentum. Product of mass. Product of mass in a sense, mass into velocity. P is equal to m into v. It acts in the direction of the velocity of the object. It acts in the direction of the velocity of the object. Linear momentum is a vector quantity. Linear momentum is a vector quantity. Here we can see linear momentum is a vector quantity. Linear momentum is equal to mass into velocity. Okay, it helps to measure the magnitude of force. It helps to measure the magnitude of force. Next we are going to see is units of momentum. Unit of momentum in SI system is kilogram meter per second, and in CGS system its unit is gram centimeter per second. Okay, the units are important. The first thing is linear momentum. P is equal to m into v. Then units, SI unit is kilogram meter per second and CGS unit is gram centimeter per second. Okay, these are the few topics we have discussed today. Okay, let's recall what is force, pull, and push. What is mechanics and its types? Mechanics is the branch of physics that deals with the effect of force on bodies. It is divided into two types, that is statistics, dynamics, and dynamics is further divided into kinematics and kinetics. Then we have defined force according to Aristotle and Galileo. Then we have seen three types of inertia and linear momentum. Okay, these are the few topics we discussed today. Success. Each steps take you closer to your goal. So start taking steps that takes you closer to your goal. Best of luck. Students, I have been in your shoes. I can tell you that with regular studies and a sense of routine, before you know it, you will have successfully completed 10th standard and move on to even bigger challenges ahead. Remember, if you have any doubts at any point as to what is required of you, just leave a comment. I'll be getting back to you by replying. Thank you, students. Please like, share, and subscribe. See you soon. Bye bye.